now we're being asked to write recursive formulas given a sequence of numbers. And so the first thing you need to do is to determine if that sequence of numbers is arithmetic and there's a common difference, or if the sequence is geometric and there's a common ratio. And so if we take a look here, we can see that the difference between 25 and 10 is 15. And then the difference between 62 and 25 is not 15. Right? So this sequence here is definitely geometric. And let's go ahead and figure out what the ratio is. Right? So the way we can do that is we can say, what do we multiply the first term by to get the second term? So we could say 10 times r is equal to 25 to figure out the common ratio. And we're going to divide by 10 on both sides, and we're going to get r is equal to 2.5. Right? And then we could test that common ratio out by multiplying 25 by 2.5. And yes, it does come out to 62.5. So this is the common ratio, and this is a geometric sequence. Right? So now that we have that, all we need in order to write the geometric sequence is a sub 1. And do we know a sub 1? Yes, it's the first term in the sequence. It's the 10. Right? So we have r, we have a sub 1, and we can go ahead and write this out. Right? The way it goes is you say a sub 1 is equal to 10, comma, a sub n is equal to r, which is 2.5, times a to the n minus 1. And then we always put the caveat n is greater than or equal to 2. And we're done. And so what am I doing here? I'm taking my r and I'm substituting it into my recursive formula for geometric sequences. It's a sub n is equal to r times a to the n sub n minus 1. R times a sub n minus 1. Right. So that's my recursive formula for geometric sequences, given that a sub 1 is 10 and n is greater than or equal to 2. So let's go ahead and take a look at this one, and let's figure, is it geometric or is it geometric or arithmetic? Right? And so what's the difference between 36 and 9? Well, let's go ahead and figure that out. We got 36 minus 9 is going to equal to 27. So this is going to be a plus 27. And then let's see the difference between the next two is 63 minus 36. So that's also going to be 27. Right? So plus 27. And let's do the last one just to check. It's 90 minus 63. And that's also 27. Right? So this is definitely an arithmetic sequence. And our d, our common difference, is going to be equal to 27. Right? That's how much each number in the sequence needed to be added by to get the next number in the sequence. So d is equal to 27. Great. Not only do we need d in order to write our recursive formula, but we also need a sub 1. Right? So we have d is equal to 27, and a sub 1 in this case is equal to 9, the first number in the sequence. Alright, so now that we're here, what do we do? Well, we're going to go ahead and substitute in here for our recursive formula, right? And d is our common difference. Okay, so let's say a sub 1 is going to equal to 9, and our recursive formula is a sub n is equal to a sub n minus 1 plus 27, where n is greater than or equal to 2. And we are done, and then we'll put a box around it. So this is how you do it for geometric sequences, and this is how you do it for arithmetic sequences.